So I'm super excited today to chat with all of you about agents, and specifically about how you can use agents within your applications workflows, how they can really help you, and then also just chat just a tiny little bit about how we at Google have created, a set of capabilities and products that can help you create your own AI agents, use the capabilities of GenAI and LLM models, and build super powerful and efficient apps. So, my name is Rukma. I work on AI products at Google Cloud. And if you've ever heard of or used products like Google AI Studio, or Vertex AI or any of that, you would have, that's kind of what I work on. So you would have touched some of the products that I spend my time on. So, without further ado, let's get into what we're going to talk about. So, first, we're going to discuss a little bit about what an AI agent even is. There's, I know, a lot of confusion out there and a lot of chat about what is that, how do you differentiate an agent from a model, etc. We're going to discuss the best ways to effectively design AI agents. Actually, a large part of this talk will focus on agent architecture and what are some interesting and cool ways to think about designing your agent. And then we might, if we have time, take a quick tour of Vertex AI, which is Google Cloud's end-to-end platform to help developers harness AI. So Vertex helps developers get APIs for 150 plus leading foundation models. So not just Google's Gemini and Imagine, but also Anthropic's cloud models, open source Llama models, etc. Vertex then gives you the tools to rapidly prototype, doing everything from evaluating which model fits which use case, running eval frameworks if that's something you'd like to do, hooking up the LLMs with custom data sources, tuning them with custom data, and then eventually simplifying production with the backing of Google Cloud Security and Reliability with some of our products like Google Kubernetes Engine and Cloud Run, which I'm sure you've heard of. All right, so let's jump into what is an AI agent. So if last year I think was the year of the model, everyone was talking models. What's the newest, release in the model? What's the newest capability? What's the newest functionality? I almost think this year is the year of the agent. Everywhere we go, all people want to talk about is agents, agents, agents. But I do think there can be a lot of confusion out there about what exactly is an AI agent, especially in the realm of Gen AI. So let's clarify our definition. So just to ground us real quick, I think we probably would have all seen or have heard of the famous Andrew Ng, who's really one of the founding fathers of machine learning, AI, and definitely the new generative AI boom. So he tweeted or X'd, I guess you would say these days, earlier this year about agentic workflows and AI agents and how those can be some of the most powerful ways to really harness something like an LLM. And starting from there are different companies, different universities, academic organizations have come out with courses, have come out with a lot of learning around agents. I would definitely say that Andrew Ng's course on this is still probably like the best, most like foundational kind of academic way of understanding more. So I would strongly recommend you go check out Andrew Ng's course on, well, almost everything, but he has a set of blog posts about agents specifically, which is super helpful. All right, so how do we define agents? Well, how are we thinking about it at Google? So an agent is different, we think, from AI models, right? AI models can be predictive or generative. They might, answer a question, generate a response, but it's basically an AI model takes in input tokens and gives you out output tokens. An agent is much more than just this kind of static system, and it's not an automated script. It's more like a dynamic, almost human-like system capable of understanding things like context, doing actions like reasoning and planning and prediction, and then taking specific actions to achieve specific goals. Something really cool about agents that I love is that agents are capable of self-evaluating themselves. So they can evaluate what action they took, and then based on the output of that action, decide what to do next. So if you were to like simplify it very much, it's basically like giving the AI the ability to think and act in real time beyond kind of just, responding to you. Okay, so here's like a more designed or architecture version of what I was literally just talking about, where we can see what it looks like when you are moving from models on the left hand side here to agents. So, like I said, a generative model, whether that's a large language model or an image model, takes in input text tokens, processes them in some format. So, if you've asked a question, it runs that kind of processing. If you've asked it to generate some creative text, it runs that kind of processing, what have you, and then outputs again tokens. So that's a generated image or text. It doesn't really take any quote unquote actions. So again, like I like to think about this always in the form of like a human being. What the model does is it can just talk to you. Whereas if you go into agents, agents can actually do stuff. So if you one interesting way my friends and I have been talking about it a little bit is some of them have young kids. And when your kids are newborns, very, very young, they can't really do anything. They can pretty much just interact with you in the format of, crying because they want something to happen to them. But they're not taking any actions. Really, you're the one taking the actions based on the data that you get from them or the interaction that you're having with them. Now, on the other side, an AI agent, and we laugh about this sometimes, is more like a toddler or a teenager or a full grown adult, where with their layers of reasoning and memory and action taking, they can go out into the world and interact with the rest of the world. For humans, we interact with the rest of the world often with the aid of our sense organs, our hands, our legs. For models, the way they interact with the rest of the world is through access to things like APIs, databases, external services. So, for example, if you imagine a flight booking scenario, a model could probably tell you, we think that you should take a flight for your trip from, let's say, Connecticut to Rome. That's all it can do. If it has access to real-time data sets, it could go one step further, going more towards that agent side of the house. It could go and pull for you a set of flights with access to, let's say, like a data API with Google Flights, for example, and say, here are like 12 flights that fit the criteria you want. One more step further, if it has access to be able to actually book the flight for you, it can do that. It will need access to your payments system. It would need access to your personal bank system. It would need access to the flights booking functionality. So there's a lot of different pieces it would need access to. And there's always a question around how much access is good to give an AI system. But basically, the distance or the difference between models and agents is those actions. So when we talk about an AI agent, we're referring to software that basically autonomously performs tasks or makes decisions. And it simulates human-like behavior and intelligence. Like in that previous example, you could totally imagine a human travel agent helping you out with all those things versus having an AI agent do that as well, freeing up the human travel agent to focus on more creative, innovative parts of the job that maybe the AI isn't capable of doing yet. So as you see in this diagram, an AI agent consists of all of these different components and interface for interacting with users. So this is where they're talking to you back and forth, getting some information on, what feedback on what they did. Is that the right thing to do? Is it not, etc. Then the second piece of it is actually the agent itself. And then you have the environment kind of layer where it interacts with all of these different outside systems using an API layer. Now, the agent itself, if you go into that little box there, since you're talking about generative AI agents, they are all based on a central kind of brain, which is an LLM, but it just extends that LLM functionality further and further. All right, so currently, I think very common, and probably all of you have interacted with or seen, are conversational agents. They're designed for direct interactions pretty much with humans, engaging in Q&A, chit chat, providing knowledge-based response. So I am absolutely certain everyone here has seen a chatbot. If you haven't, ping in our chat, and I would love to direct you to various chatbots that exist out there. But what I'm really seeing the future going, and where we're really seeing the future going, is this concept over here that we are calling workflow agents. So, you might think, Rukma, what's so great about workflow automation, right? We've had it for the longest time, so many tools and software out there, RPA systems, Blue Prism, even things like Zapier, which try to make it lower code or no code. What's so great about a workflow agent? Well, the top thing about an automated AI workflow agent is that you have to code approximately 10x less than what it would take you to use some of those previous systems. An email comes into your inbox, the agent reads it, it categorizes it, formulates a response, creates a Jira ticket, maybe even adds a priority flag to the Jira ticket. See, I would love it. I was out of office for a week and I came back and I had 543 emails. And if instead of having to spend my time triaging all those, I had an email AI agent that triages that, awesome. So what are the key differences then, you would say, between something like this and like regular old like garden variety workflow automation? Well, first, very low code, like I said. And then second, much, much lower or minimized human interaction, right? So this kind of workflow agent will be event driven, triggered by some sort of event like email enters inbox. Then it has read functionality, so it'll go ahead and read it. It'll run some processing, and then it will decide, like, how do I want to triage this? Where do I want to put it? The fact that these kinds of agents are based, like at their heart, on natural language processing models like large language models basically means that instead of having to convert every like human event, like this, if this email has these keywords, it's a high priority email, you can just rest assured that the LLM will actually understand your email, will read and understand it. And even if it doesn't have those high priority keywords, it'll make a decision based on, hey, this is coming from your director, or this is coming from your boss. Let's make sure that this is actually high priority. So I think that's where we think some like really exciting use cases, especially for people like knowledge workers, can come in. I see a question here about cleaning inbox. I am not sure if the Gemini email client exactly can. This is a great question. I'm not on the Gemini email client team, but it's a great question, and I can find out about you. I know what it does currently is help you generate like pre-generate responses. So a lot of the time, all you need to do is respond and say something like "Thanks, noted," or "Going to do this next week," or something like that, and it kind of pre-fills that for you. I've seen that functionality. I think I don't think it's hard to program an agent to clean up your inbox. So we can definitely talk about how we can use existing functionality to like make that happen. Okay, cool. So now that we've covered kind of what is an AI agent and some of the things it can help you do, let's look a little bit more at the architecture here. So like I said, so now we're deep diving into that agent box that was in that previous slide. So like I said, the model is the brain of the agent. So it understands natural language queries such as like find me a flight to New York. It The model might also make some decisions on which secondary model to use. So suppose it's like, oh, this is a query that I should send to an image generation model, or this is a query that it makes more sense to send somewhere else. It might make those decisions. It might have to do some decision making around things like which database to access to get information. For example, if you're asking about like, HR, like what kind of benefits do my employees have? It's going to want to go to one specific database versus another specific database that doesn't have that info. And those efficiencies are actually a non-trivial problem trying to figure out where to direct a query. And a solid model, like a really good model here, can help you with that. A key thing to remember here, and I will really stress this, which model you choose and the training data of that model plays a significant role in the agent's ability to be effective for your use case. Okay, so what do I mean by this? Let's say a healthcare company or a hospital, and you want to use an AI agent to help your doctors diagnose or triage like higher risk versus lower risk, etc. Cases. So you want to send it some pictures of X-rays, let's say, or MRIs or scans, and have it predict like this set might be higher risk and needs a doctor to look at it versus this set is lower risk. Using a large language model, something like the ones that are out in the market right now, may not work very well at all for this because those models are trained on text and how to respond to text. So if this is the kind of agent you want to build, you would need to get a hold of your own kind of custom model that's trained on your custom data, or you can fine tune one of our existing models on a set of custom data. So I'll just highlight this, that if you're building an agent, that choice of which model based on which use case is really important, and I would recommend you definitely spend time thinking about that. So that's the model piece of it. The tools are what extends that agent's capabilities, using Google Flights API to fetch flight data, etc., like we were just chatting about. It can have access to your Gmail if you wanted to. Different APIs expose kind of different functionalities, and you can basically allow your agent to do whatever you want it to do. And then finally, kind of what brings this all together is the orchestration or reasoning loop, or you may have heard it even called reasoning engine, and that is kind of where one says the magic happens. So some people will, say that you need three things for an agent. Some people will say five, eight, whatever. This is like absolutely essential and what defines an agent, the reasoning engine. It's an agent's conductor, which basically means it does all of this stuff like managing memory, maintaining state, handling like relatively complex tasks like multi-turn conversations, learning how to direct a query to the right tool. It is a pretty introspective and iterative process, which let me kind of just repeat that. It's an iterative process, which, is extremely cool because in the past, all of our available systems, if you wanted it to run a process again or loop a process again, you would just have to add, specific if conditions, specific end and start conditions, or you would even have to have a human interact and provide that feedback. Whereas here, the reasoning engine does this work itself. It'll evaluate like, hey, did I actually give this person a set of flights that work for their criteria? And if it hasn't, it will go back and run all of the functionality one more time until it gets to a place that it feels is a legitimate response. So I think that, like for me, I think that is just very super cool. So I think we chatted a little bit about this, but since we are all hands-on people, I'll focus on a couple of things to think about when you're creating your agent. So one is profile and instruction. So this is where you define your agent's personality and mission. So you say something like, you are a travel agent, friendly, focused on finding flights that fit your users' queries. You can say stuff like, make sure you ask the user enough questions until you have all of the data needed to provide the correct flight. Here, profile and instructions is kind of where you shape its persona, and then also importantly, define how it interacts with the user. I'll say from my experience building agents, the more you tell it to ask the user questions, the better results you're likely to have. So remember to tell the agent to ask the user a bunch of questions, essentially. Then you have memory. So there's obviously, everybody knows there's like short-term and long-term memory. And when it comes to agent architecture, you want to think a little bit about what you wanted to hold on between sessions versus what you want to have only as intra-session memory, right? So things like remembering flight options, remembering a person's general preferences on seats. These are things you might want to store across sessions versus PII data used to actually book the flight, financial data. You definitely don't want to store across sessions and just have that deleted at the end of a session. And then finally, you are also going to kind of give it some instructions on what kinds of reasoning and planning the agent does. So you want to use some kind of specific approach where you tell the agent, first, when you get a query, I want you to think through X and Y. then I want you to access the databases that are likely to have this kind of data. Don't, I would say in this one, err on the side of giving the model more independence. Like the more you define it, the less likely it is actually to be super powerful and exciting, because at that point you're just kind of going back to regular old workflow automation where you're like, hey, if this happens, then do this. Whereas the whole point of an AI agent is that it knows what to do, kind of based on what is going on with the user and the feedback it gets. Okay, so I gave you an example of kind of a flight um, booking system, and this is another example of a more enterprise or business to business example where we're thinking about HR. So the process begins with the user asking, how does the new benefits plan compare to my existing benefits plan? Great, let's go into what the agent does. So the first step the agent is going to take is ask it a bunch of questions. Suppose it's got all the answers that the user has provided, it's going to develop like kind of an initial plan using that LLM. So the initial plan might be something like step one, retrieve new benefits plan. Step two, retrieve the existing benefits plan of this particular user. Step three, compare the information from those plans and generate a response. So, okay, that sounds very easy, but it's not necessarily. Like, which database does the new benefits plan live in? Is it in Workday? Is it in like a existing like set of documents? Where do we get the existing benefits plan of this user? What information do we need from this user, like an employee ID or something like that, in order to find that person's existing benefit plan? How do we know to ask the user those questions? So all of this work is being done by your LLM, and how quickly and efficiently it does it is very strongly, I think, dependent on how well you set up that initial architecture that we were just talking about in that previous slide. So let's say the agent then starts executing the plan steps. It, let's say, retrieves the new benefits plan from a RAG index of information it has with like all of the HR info. Then it's like, great, okay, how do I retrieve this user's existing benefits plan? So it goes back to the user and is like, hey, I need your employee ID. The user gives it the employee ID, goes into something like Workday and gets the existing benefits plan. Then finally does the comparison and provides an answer which the user can of course interact with. So the user can then say, this is a great comparison, but I'm really interested in like dental and visual benefits. So can you like deep dive more into that? So this is just sort of an example of what that kind of looks like and how the LLM is able to be super dynamic and kind of go back and forth between the backend databases, the user interaction, the kind of actions it needs to take, and create all of that in this like very seamless sort of experience. This is just another example very similar that I just chatted about. This is customer service. So I don't think I need to go super deep into it. We also have only 10 more minutes before our exciting Redis speaker. So I'm going to go really quickly into talking through benefits. I think, maybe this is me belaboring the point here, but I think like you probably already get this. But I would say the three top benefits to think about when you're thinking about building an AI agent is one, really excellent user experience. So fast, dynamic, high context user experience makes a company's customers happy, makes a user happy, helps them do anything from find information to set up calendar events. Second, improving operational efficiency. So, the more routine tasks you can eliminate, things like, those 400 emails I had in my inbox, the more time it frees up for your human employees to really focus on the creative stuff, on the innovative stuff, things that machines can't do as well as humans, and just like automate away all of the boring stuff, the broccoli. You can like over here think about everything from like processing tickets, monitoring inventory levels, figuring out supply chain, automating finance and procurement and processing all of that. All of these things are things AI agents can very easily and accurately do. And then finally, it also is a very natural user experiences. So unlike sometimes with existing chatbots where you're talking to a chatbot and you're like this is just a very limited set of functionality and things that this particular agent or bot can do that you won't really understand my context and answer my personal question. Something like an AI agent has that like very human kind of way of answering queries and dealing with your users. Cool, cool. So I think we've covered AI agents, what they are really quickly, a little bit about design and some kind of tips and tricks to think about as you design them. And then let's now talk a little bit about how we at Google Cloud can help you do all of this stuff, from everything from no code to very high customization, high code ways to do it. So Vertex AI provides essentially a suite of tools that helps you do, as I said, everything from pulling in a model into your existing app to fine tuning to adding a custom data source to even creating and productionizing an end-to-end agent app. So just to ground us very quickly in the timeline of AI, we started our journey to get here with predictive AI, predicting like a very specific defined output. Then we moved into generative AI, like generating these creative outputs that aren't easy to like measure with the same way that predictive AI is, for example. And then finally, now we're in the era of multimodal generative AI. So the input systems can be everything from audio to video to pictures to text, and so will the output be, which I think is pretty cool. And what we see is all across the enterprise, for each of these types of AI, workflows can be simplified by agents. This slide just shows you kind of some of the different areas where you can very quickly think of where AI agents will be relevant and useful, but this is by no means exhaustive. Like, basically your creativity is your limit. Someone asked me at a meetup I was at a few months ago, hey, like, what do you think are the top use cases of AI? And I was like, well, that's a little bit like asking someone what are the top use cases of the internet. Like, pretty much your imagination is the limit. Like, the internet you can use to do absolutely anything, and in my view, like, so is AI. You can use AI pretty much in whatever way your imagination takes you. So the AI ecosystem on Google Cloud includes Vertex AI that I was just talking about, which helps you build Gen AI apps. You can use Gen AI, obviously, using the Gemini model family for Google Cloud, but also I think I heard someone say about Gemini email client. So, it's in your email. You can just go to like Gemini and chat with the chatbot version of it and all of that. And then also I want to highlight that we do have an open Gen AI ecosystem with our partners, which is really important to make sure that we're allowing our customers to pick the right model for the job, whether it's Google or open source or third party, and that we are partnering with infrastructure partners to make us the best place to both build and use Gen AI. So I am going to dive just kind of a little bit into the Vertex AI part of what I just showed you. And I have 5 minutes. So we're going to do a whistle stop tour through all of the Vertex AI capabilities. So at the bottom, as you see here, we have our AI hypercomputer infrastructure with the best GPUs and TPUs. And that's our Google Data Cloud. Next, you have Model Garden. Model Garden, which is a part of Vertex AI, is where you can start your AI work. You can find the best foundational models from Google, from the open community, from our partners like Anthropic and Meta. You can find specific models that are intended for medical use cases, for analytics use cases. You can, pick your own models. You can fine tune them, what have you. Next, we come to Model Builder. So this is the next kind of layer within Vertex AI. Here, you can customize your model. So you can add any custom data source, and we make it super easy. It's honestly just like 2 clicks to add everything from like a Salesforce to a cloud bucket, obviously, to if you just happen to have all of your data on Drive, you can do that as well. And you can augment your models if you want to, let's say, run an evaluation on, is this model the right one for my use case? We have a bunch of pre-packaged evaluations that you can just open up in like a Colab notebook and run. You can bring your own evals if you would prefer to bring your own eval frameworks, make it very easy to do that as well there. And you can basically set up your end-to-end data pipeline and make sure that, the LLMs run on data or Gen AI runs on data. And so making sure that you have the right data pipeline and you have the right level of customization, whether that's just hooking up a custom data source to RAG, all the way through to like fine tuning a model on your own custom data, which of course is like vastly different levels of energy efficiency as well as just compute efficiency, and also are not like, you don't need to fine tune a model for most use cases when a custom data set will do. So you can do all of these things in model builder. And we are running out of time, but I'm happy to chat model builder or Vertex or any of that. So just send your questions in through AI Camp and that awesome group, and I'd be happy to answer. And then finally, you have the agent builder layer. So everything we've been talking about today, we make it very easy for you to come in, set up an agent, attach it to a custom data set you have. We even pre-package certain very common agent functionality like search, for example, with some pre-wrapped APIs that basically lets you make one API call instead of having to design a bunch of code and make four. So you could think about Agent Builder as the place to start. So I would definitely say that if after this talk you're interested, you want to try your hand at building an agent, you want to see what Google Cloud offers, just go into your browser and search for Vertex AI Agent Builder. And also the link is just agentbuilder.cloud.google.com. And you should be able to very easily, without actually writing much code, get started building some cool stuff. So again, like I said, there are some really cool things about AI Agent Builder, and you have not only the best models from Google and across the industry, you have that end-to-end model building platform with the ability to customize it at pretty much every level you want and just do exactly what works best for you in the most efficient way. You have the ability to develop and then also productionize agents faster, in a more efficient way, and grounded very easily in your custom data set, in the particular data that makes sense for your use case, for your context, for your company. And then finally, I will also highlight that since this is a Google Cloud product, if you're ready to productionize, it is backed by enterprise readiness and all of our security and compliance and reliability and efficiency and cluster management just comes kind of along with it and removes all of that headache of thinking about how to productionize, how much is it going to cost, how am I going to manage it, blah, blah, blah. Okay, I am actually going to skip Model Garden. I think I was pretty clear on what Model Garden is. And since today we were mostly talking about Agent Builder, I will leave us mostly with that idea that go into Agent Builder and you should be able to get started with one-click building. So I actually asked Gemini, like, hey, what are the top 3 takeaways from this talk? I've given this talk once or twice before, and I entered it into Gemini and asked it what the top 3 takeaways are. So I'm going to leave this slide up here that gives you the top 3 takeaways for a minute. So if you want to take a screenshot or not, no guarantees for how perfectly relevant this will be to you, but I thought Gemini did a pretty decent job. And then finally, before passing on to our partner from Redis, I would love if you could please scan this code and take a 1-minute survey. And I believe the lovely folks from AI Camp have also been pasting this in the chat. We love to hear about how we did. Did we bore you? Should we have talked a little bit more about something else? And we can keep improving as we have a lovely set of events planned with AI Camp all across the world, as well as virtually. So please tell us how we did. I hope to see you in person in some of those events. And if you have any more questions, please send them along and I will try my best to answer them. And with that, I will pass it over to Redis.
Awesome. Thank you very much. And now I'm going to go through and hopefully, well, first let's do the mic check. Can people hear me?
Yes, we can hear you.
Yes.
Perfect. Now, the real challenge is, let's see if I can share my screen. Hopefully you're all seeing a big red block.
Yes, we can see your screen.
Perfect. All right, let's dive right into this. And thank you, Rukma, for that excellent presentation. Yeah, so a bit about me. My name is Justin Cechmanek. I'm a senior applied AI engineer at Redis, where I work on all things for generative AI and large language models, specifically vector databases and why everyone should be using a vector database to build out your applications. So a bit about Redis and how we play inside the AI ecosystem. You've probably heard of us as a cache. We're more than a cache, though that is actually a big use case that we do support. Within the world of generative AI, we are the context retrieval. We are the retrieval stage in retrieval augmented generation. We also act as your memory layer. So if you need any type of conversational memory, because LLMs by themselves are naturally stateless, Redis is a natural choice to keep your conversational history and post-session history data stored and accessible as well. We also build out tools to enable semantic caching and semantic routing, which we'll talk more about in this talk, and why you can also build out those tools and add them to your LLM applications. We also build out feature stores, and we power search engines on hundreds of millions of documents, and we build out custom personalization recommendation systems, fraud detection systems, you name it. There's quite a bit more than just
Sorry to
caching.
interrupt you, Justin. We cannot see your slides.
Oh, I'm
If you
sorry.
can reshare, yeah.
I
Is it?
actually can't see the slides. How many people are having challenges?
I think
All
Rukma, you
right.
need
Yeah,
to stop
now it is
sharing
working.
your screen. That seems like a two screen being shared now. Okay, should be fine right now. Go ahead.
Yes,
All right.
everyone in the chat is saying it.
Wonderful. Glad that's working out. The joys of Zoom calls. All right. Yeah. So that's only a small list, honestly, of some of the things we support. We also have a very wide development tooling environment. So we have integrations into Llama Index, Spring AI, LangChain, several others. We also have our own custom-built Python library called Redis VL or Redis Vector Library, which is tailor-made to support large language model applications to make it very easy to stand up your own RAG system and add things like caching and routing and session history and management of memory into your applications. And of course, all this is built on top of Redis, which is consistently measured as the fastest in-memory database and vector database. So now let's talk about how you compare Redis to generate really cool GenAI apps with Google Cloud Platform. First, we have to talk about retrieval augmented generation, or RAG. If you're building out any type of LLM application, really RAG is table stakes in terms of building something. And it's easier to get started with than you think. This is the standard RAG flow that we always show to people that want to get started. You start with a user that has a query. They take that query, you embed it through a Vertex AI embedding model to generate a semantic representation of that, which is essentially just a vector. That vector is now your search term to hit the Redis vector database to do the retrieval stage of retrieval augmented generation. Collect all the relevant documents from your data store, pull out the text from only the relevant documents, not your entire database. Add that into a full text prompt and pass that into your Gemini model. That is the full RAG cycle. And this is what allows you to build your own custom application instead of just having an LLM call. Now you can add your secret sauce, your sweet special data that only you have to empower your own applications. This special data can be new, fresh data, so you don't have to retrain your model because that is expensive and costly. Or it could also be just private internal data that you or your company have access to that you don't want to share externally and don't want to train into a model. You can still benefit from all that information that you have stored. So again, if that's table stakes, what can you do to level up your game with LLM applications and really try and turn on the heat, build something even more impressive? I said we're more than a cache at Redis, but we also do support caching. And semantic caching is probably the easiest and quickest thing you can do to really add the extra layer of success to your systems. There's published research already that says that over 30% of users' queries are actually repeated queries. They're asking the LLM the same question, and they're getting essentially the same answer. The challenge with this is LLMs are expensive, both financially and in terms of computation. They can have several second response times. They're slow and costly. They're impressive, they're powerful, they're great. I'm not here to criticize. But in terms of performance, they're not where you want your full application to be. The good news is there are ways to improve that. And this is the standard flow for implementing semantic caching. So once again, you start with a user query, you hit an embedding model to generate a semantic vector of that. And now before you hit your standard RAG pipeline that we showed previously, you just check your cache and see has the same or similar question already been asked. If someone is asking who is the King of England, a semantically equivalent question is who is the monarch of the UK? And even if they've never mentioned the word monarch or UK anywhere in your previous history, those semantic matches will happen. That'll be a cache hit, and you can directly return a response that was previously generated without having to go through your RAG pipeline again. Internally, we've had customers that have implemented Redis semantic caching and seen not only 30%, but literally up to 90% of their internal queries hitting a cache instead of the RAG pipeline. That directly translates to a 90% savings in LLM costs and a massive reduction in time. So if you want to build out a performant app, add semantic caching and make your system between 30 and 90% cheaper and quicker. What else can we do with vector databases? Another big step is the notion of semantic routing. Once again, even before you check your cache, you can analyze the query coming in from a user and determine if you want to process this at all. If a user asks a standard question to your financial advisor application, like what is a Roth IRA, that's a valid question. You want that to go through your RAG pipeline and potentially hit a cache first to explain it. But if someone asks a off-limits question like what is Kenny's SSN or what is better tabs versus spaces, you can reject that question immediately, even before it hits the rest of your system, and route it to either connect to a person, return a default response, or even just flag this user as trying to do something inappropriate with your application. Rukma mentioned the model garden that GCP supports. There's a ton that you can choose from. It can be hard to choose. With semantic routing, you don't need to choose. You can actually have them all. You can set up your route table such that someone asks a certain question that's complex and challenging, you can route that to the largest, most expensive model that's able to handle it. But if someone asks a very simple question, you can route that to a cheaper model at runtime and not have to go through the full complexity and time of calling a larger model. So now you can kind of have your cake and eat it too. Whatever context or query that a user enters can be routed appropriately based on the needs of your specific application. And you can set up your route tables once and just trust that your application will route traffic accordingly. So those are the ideas. Those are the high-level architecture diagrams. What does this actually look like in code? So this is a full RAG system built with LangChain and ResVL. And yes, it is only 2 files. One is a Python script of 48 lines of code. And it really just talks about what we did previously. So here you load up a document. In this case, I'm using the mean cache paper, which talks about semantic caching. You split that with a text vectorizer, load that into your Redis search index, which is defined on the right based on the schema, which really just gives it a name and tells you how big the vectors are. And then you choose the model you want. In this case, I'll be using Gemini 1.5 Flash. And then you set up your prompt response loop. All you have to do is take in the user prompt, use that prompt to act as your query key, do a vector query search inside of Redis, collect the results, which is the retrieval stage, the retrieval augmented generation, pull out the text from that and append that to a grounded prompt. So the final prompt you send to Gemini is, the full context you retrieve from your vector database and the user's question. Pass that along to the model, get the response, and return it to the user, and repeat the process. This is how easy it is to get started with RAG, and yes, I'll share this out with anyone that would like it afterwards. I encourage everyone to start building with these. It's worthwhile to get your hands dirty, roll up your sleeves, and really try it out for yourself. But once again, if this is standard table stakes, how can you level up this system? So let's talk about just adding semantic caching. So once again, I kind of stripped away everything. So on the left is the most bare bones LLM app you can possibly have. It's just a prompt response loop, taking in the user input and calling a Gemini model, returning the response. In this case, just printing it, not even storing it. How do you add caching to this system? It's easier than it looks, and that's what it looks like on the right. It's basically 10 more lines of code. You import it, you instantiate a cache as a semantic cache, you choose your vectorizer. In this case, we're using Vertex AI once again. And now every time a user has a prompt, you just check your cache first to see if there's a matching question. If there is, you return that question's response that you've already computed and already stored in the cache. and you continue to the next question. No need to call the LLM at this prompt. If that's not a hit, it means no one's asked this question before, this user doesn't have access to that area of the cache, then you do go ahead and just call the model as you would in a standard RAG pipeline or standard chatbot pipeline. Don't forget to store the data in the cache for the next step. And once again, you continue. And that's really it. Once again, 10 lines of code can improve your system by between 30 and 90%. So I encourage everyone to try and get started with these things. Oh, and let's see. There it is. Yeah. Hopefully that was useful. Hopefully that encouraged some people to actually, start building some of these things and playing around with these tools. It's easier than it sounds. Hopefully I've communicated that. If you want to learn more about Redis, please check out our Redis released worldwide ongoing talks and presentations. And if you want to learn more about Redis on Google Cloud, please check out our offering on the Google Cloud Marketplace. And that is it.
Thank you so much, Justin. Looks like there's a few questions in the chat.
Oh, let me bring up the chat.
It says, how would you define what is complex or a simple question?
That is based on your specific application. So again, if you're building, like, say, a financial assistant app, you probably have an idea of what frequently asked questions are. So things like, what is a Roth IRA? What is a 401k? That's a simple question, I would argue, in terms of that application's use case. If someone's asking, like, please give me a detailed analysis of this company's 401k, or 1099 filings or other documentation where you have to analyze a lot of intricate data, and you want a very nuanced response, that's a more complex question. And again, with route tables and your notion of frequently asked questions, you can figure out what these things are.
Perfect. And someone asks, why did you use Vertex AI instead of semantic?
What do you mean semantic? So Vertex AI in this case is a semantic similarity. I mean, and then eventually it's a embedding model. There are many to choose from. I chose Vertex AI for this application because it's one that we natively support within Redis VL. But you're free to choose any other ones. The system, works equivalently with any vectors of your choice.
Someone asks, when caching, do you do exact match or approximate match for query?
So we do approximate match based on semantic similarity of questions. So once again, the example I used is, if someone asks the question, who is the King of England, or who is the monarch of England, that wouldn't be an exact match because king and monarch are very different, but semantically they're equivalent. And so because we're doing vector similarity based on semantic similarity, those would probably be a cache hit, but you can control the preciseness of that cache hit.
Perfect. And I guess one more, do you use the same embedding model as used for RAG for semantic cache or semantic routing?
I usually do, because if you have a good model for your application, it makes sense to use everywhere. You don't need to. So if you wanted to use those things separately, you absolutely can have one model in your retrieval stage, another model in your caching stage, and a third model in your routing table.
Thank you. That's all we have time for this morning. Thank you all so much. And thank you, Justin, for being our guest this morning. We truly appreciate you.
Thank you.
Thank you, Justin. Thank you, Rukma. Thank you all. Thank you for joining us today. I would like to take your 1 minute to complete this short survey to tell us how was it, how did you find it, whether you learned something or not, or like share your thoughts so that we can improve our upcoming events.
All right. Looks like we have 95 people still on, but we appreciate you all this morning for your time. And it was an amazing talk by both Rukma and Justin. And thank you so much, AI Camp, for allowing us to be here.